In this lesson, we are going to be working on our player controller. Now, this is going to be the blueprint that controls our player's movement, its jumping, and also eventually its logic, such as being able to eat, sleep, take damage, and heal. Now, the first thing we need to do before actually setting up our player controller is setting up our inputs, which are going to control our player. So, to do this, we're going to go to our content folder here, and we are going to create a brand new folder inside of our content drawer here called inputs. Now, inside of this inputs folder, we are going to create what's known as an input map context. So for this, we're going to go down to the input and then go down to the input mapping context. This is basically an asset which is going to contain all of our different actions, such as moving, jumping, and then later on, if you want other interactions, such as the pause menu, attacking, interacting, stuff like that, which we can then assign keybinds to. So we're going to select input mapping context, and we are going to call this one our input map main. Now, we're going to double click to open this up, and inside of this window here, what we are going to do is begin setting up our mappings. Now, our mappings are basically, like I said, our actions. Now, for this player controller, we are only going to have two. Our first one is going to be called move, and this is going to basically take the W, A, S, and D keys and provide two different axes, okay? The left, right, and forward and back axes that we can then plug into our controller to move ourselves around. And the second one is going to be jumping with the spacebar. So to begin, we're going to click on the little plus right here to add a new mapping, open that up, and down here where it says none, we're going to click on that drop down and create a brand new input action. Now, we're going to go to our inputs folder, so make sure you're saving everything there, and we're going to call this one move. Hit save, and there we go. Now, before we actually begin assigning keys to this mapping, what we're going to do is we are going to go into our content drawer here, and we are going to open up this move input action. Now, the reason why is because we need to modify a few things. First of all, down here where we have value type, we're going to change this from a digital boolean, which is basically true or false, whether or not it is being pressed, and we're going to change this over to an access 2D vector 2. Because since we are taking in four keys, the W, A, S, and D, we want to basically convert that into a vector direction for us to move in. So that is why we need to change that right there. We can then save that, go back to our input map main, and now we can basically fill out the different keys for our move input action. So the first one is going to be moving forward, so I'm going to click on this little key value icon here and press W, and you can see that adds the key here. We can then add another by clicking on the little plus icon. This one is going to be S. We can add another. This one is going to be A, and the next one is going to be D. So W, A, S, and D. Now, we don't want to leave it like this because we now need to make it so that each of these different keys modify the mapping output in some way. So to do this, we are going to add what are known as modifiers. Because right now, if we were to press W, the output of the move input action would be 1. So basically the way we want to do it, I'm just going to open up Paint here so that we can have a better understanding. So we have W, we have S, we have A, and we have D, okay? And this is basically the 4 different directions that we can move on our keyboard. So when we hold down D, this is going to return a value of 1, okay? And when we press A, that is also going to return a value of 1. So what we want to do is make it so that when we press A, the output is reversed. So instead of 1, it's going to be -1. So we need to negate that, okay? We need to add a negative modifier. Now, when we press W, that is also going to be equal to 1, but we don't want this to be the same axis as this one. Instead, we want to separate that so that the 1 here is going to be on the y-axis instead of the x. So we need to what's known as swizzle that input axis value. And then for S, we want to swizzle it so it is along the y-axis and also negate it so it is -1. It's a bit of a weird thing to think about in the way that we are setting up this input action, but basically we are having an input. That input, when we press it down, by default returns 1. And what we want to do is basically choose to map it on the X or Y axis. By default, it is on the X. So if we want to map it to the Y axis, we have to swizzle that or add a swizzle modifier. And if we want it to be -1, we need to add a negate modifier. So let's go ahead and do that now. So for W, we want to first of all swizzle this. So down here at modifiers, we're going to add one, and we're going to set this to be swizzle input axis values. And as you can see, it says useful to map a 1D input onto the y-axis of a 2D action, which is what we want to do. And then down here for S, we want to add two modifiers. The first one is going to be swizzle, and the second is going to be negate, meaning it is going to then be a negative for S, which is basically us moving backwards. Then here for A, we just want to add in the negate modifier, and for D, we don't want to do anything. So now what we have it set up so that when we press W, that is going to return a axis of 0 on the X, 1 on the Y. When we press S, that's going to return 0 on the X, -1 on the Y. When we press A, that's going to return -1 on the X and 0 on the Y. And when we press D, that is going to return 1 on the X and 0 on the Y. Okay, so again, it's a bit hard to comprehend at first, but hopefully as we continue on and start plugging this into our actual player controller, it will begin to make more sense. And next up, we have another mapping, which is going to be for jumping. And this one is a lot simpler. So we're going to click on none and create a new input action like before. Call this one jump. And inside of jump, we just want to set the key value here to be spacebar. And that is all we need to do, okay? It's a lot easier than setting up our movement input. So we can then save this, go back into our main level, and in the next lesson, we can begin setting up the actual player blueprint so that we can begin connecting those inputs and moving our player around. So thanks for watching, and I'll see you all then in the next lesson. Welcome back everyone. In this lesson, we are going to begin setting up our player controller. So what we're going to do is we are going to open up our content drawer here. We're going to go back to our main content folder, and we're going to create a new folder called blueprints, which is basically just going to contain all of our blueprints that we're going to create from here on. So I'm going to create a new folder, call this one blueprints. And inside of here, we are going to create a brand new blueprint. So we're going to right click, we're going to go blueprint class, and we are going to go down to where we have character. So we'll select character, and we are just going to call this one player. Now we can double click to open up the player. And inside of player, what we're going to do is we're going to set up our components first of all. Now, for now, we are just going to be adding in a camera, but later on, we're going to be adding in our needs. So for now, we're just going to click on the add component button at the top left corner and search for camera. There we go. Now with this camera, we want it to be up around eye level. So I'm just going to drag this up to about here. There we go. And there we go. So now we can rotate our camera and it's going to be basically at where the player's eyes are. Okay, now you'll also notice here that we have a character movement component, and this is what's going to handle all of our movement. It's going to manage walking over terrain, jumping, sliding, velocity, all that stuff. So we actually don't have to do a lot of nodes and blueprinting in that regard. A lot of it is actually taken care for us already. So if we select that node, or if we select that component, and go to the details panel, you can see here there are a large number of settings for us to modify, such as its general movement, the walking, the jumping, falling, all that sort of stuff. We're going to have a look at this a bit later on once we actually have the inputs and everything set up for us to move around. So for now, what we're going to do is we're going to compile this, we're going to save it, we're going to go back to our main level, and the reason why is because right now if I press play, we don't spawn in as our player, okay? We spawn in still as a sort of free cam that flies around. So what we need to do is create what's known as a game mode, and this blueprint is basically going to tell the game what blueprint it has to spawn in to act as the player. So I'm going to open up our content drawer again, and I'm going to create a new blueprint. This one is going to be of type game mode base, and I'm going to call this one game mode main. We can then double click to open it up, and inside of here, all we want to do is go to the details panel, go down to where we have our default pawn class, and change that over to our player. We can click compile, save it, get out of there. And back in our level, we're going to go over to the right-hand side where we have world settings. And inside of world settings, we just want to go down to where we have our game mode override and set that to be our game mode main. There we go. So we can then save that, press play, and as you can see, we are now our player. We can't move around or do anything because we actually haven't set any of that stuff up yet, but we now have our player here that we are now possessing, which is great. One thing you may notice is that our player is not standing on the ground, they are below the level. So to fix this, we are going to select our player start actor right here and move them up to the top. This here is basically just going to be our player's spawn position. Now, if we move it up top and press play, you'll see that our player is now at the top of the level, which is great. So the next step is going to be actually getting some movement into our player. So how can we do that? Well, let's go over to our player blueprint, and we are then going to go over to the event graph. Now, inside of the event graph, this is where we are going to be setting up our nodes. Now, to begin, before we actually start setting up our movement inputs, our jump inputs, we need to actually connect this input mapping context to our player, because by default, these movement and jump inputs, our player does not know about them. It does not know to listen to them. It doesn't even know they exist. So what we have to do is basically add that mapping context to our player blueprint. Now to do this, we are going to go to the begin play node here, and just for now, I'm going to delete the actor begin overlap and event tick node since we are going to be needing those. And here what we're going to do is we're going to start by getting our player controller, okay? Because whenever our player pawn gets spawned in, it also gets spawned in a player controller, which is sort of the more abstract data-driven component for our player. Whereas the pawn is the actual physical actor in the world, the player controller is sort of in the background managing our player's inputs and sort of driving them forward. So to do this, we're going to create a node called getController. Now with this getController node, we then need to cast this or convert it into a type of player controller. So we're going to return that value out into a cast to player controller node, and this here is going to return the player controller, and it's going to execute from the top one if it was successful, or from cast failed if it was not able to. So we're going to plug this into begin play, and then we are going to plug the as player controller into the enhanced input down here. Okay, you should see a node called get enhanced input local player subsystem. And this is going to plug into the add mapping context node, which we can continue the execution flow from cast player controller. And down here where it says mapping context, we're just going to set that to our input map main. Now, what this here is doing is basically we are pretty much getting our player controller and attaching to it that input map main input context. So now, whenever we press inputs, we are going to be able to read them and do stuff when they happen. So the first one, which is probably the most simplest, is going to be jumping. So here I'm going to create the jump input event. So I'm just going to type in jump. And if we scroll down here, you should see there is an enhanced action events category with the jump event. Now, if we create this node here is going to be triggered whenever we press the space bar. And when that happens, we want to jump. Now, with this character movement component, like I said, it has pretty much everything set up for us automatically. So all we need to do is plug this triggered execution into a jump node. And that is all we need to do to get our player to start jumping. So if we save that, compile it, press play, we should be able to press space. If I move this over here, if we press space, we can now see that our character jumps. And if I hold down space, they will continue to jump. So there we go. We can see successfully now that the inputs are working, and we can actually trigger some events when those events are pressed. Okay, and in the next lesson, what we're going to do is begin setting it up so that we can then move around with the W, A, S, and D keys. So thanks for watching, and I'll see you all then. Welcome back everyone. In this lesson, we are going to continue on with our player controller. And in this lesson, we are going to start with setting up the ability to move around with the W, A, S, and D keys. So to do this, we are going to create another enhanced input action event similar to jump here, but instead for movement. So I'm just going to type in move and scroll down to where we have the enhanced action events here for move. Now, move here, whenever the W, A, S, or D keys are pressed, the triggered event or the triggered output will be executed. And the action value here you can see is of type vector2, so it has an X and a Y value. Now, what we want to do is first of all normalize these values, because the way that movement is set up, and a very common error that people run into, is by not normalizing the input. And what this basically means is that if we are pressing W, the length of that vector is 1, whereas if we press W and D, okay, that is giving us a 1 for the X and 1 for the Y. Now the length of that vector is around 1.4, so that basically means that if you're moving at an angle, you're moving faster. And we want to prevent that. So we're going to do this by normalizing that value, which basically means we are converting this vector and limiting it to a range of 1. So we're going to plug action value into a normalize 2D node here, and it's going to have a return value. Now, this return value, we actually want to split into its X and Y axes, because we want to basically add that movement separately from one another. So I'm going to right click on return value and select split struct pin. And you can see here now, instead of it outputting a vector 2, it is outputting 2 separate X and Y floats. So what we're going to do now is set up our left and right movement with the X value here. Okay, so if we press A, this is going to be -1, and if I press D, it's going to be +1. Now for this, we're going to plug that into an add movement input node. Now add movement input, this here basically takes in a world direction and a scale value, and it moves us along that axis. So I'm going to plug this into the move event triggered execution flow, and I'm going to plug the return X into the scale value. Now, to move left and right, we want to be moving along the Y axis, okay? So I'm going to set Y to 1, I'm going to save, compile, press play, and now if I press A, I'm going to move left, and if I press D, I'm going to move right, which is very nice. So we can then do the exact same for the Y value, which is going to control our X direction. So for this, we're going to copy and paste the add movement input, move it over there, plug it in. I'm going to set the X to be 1 and the Y to be 0. And then we are going to plug in the Y into the scale value here. Okay, so this is basically what we are doing. Now, if I save that, compile and press play, you can now see that we can move forwards, back, left, and right, which is very nice. We can jump as well. But we aren't exactly done with this movement, and there is a big problem with this that we are soon going to discover when we add in the ability to look around with our mouse. So let's set that up as well. Now, to look around with the mouse, basically what we're going to do is we are going to get the X and Y inputs from our mouse movement, and we are going to rotate the camera based on that. So for this, we're going to create 2 event nodes. We're going to create mouse X, which is going to be the mouse events here, and mouse Y, which is going to be under mouse events here, not mouse values. So mouse events, mouse Y. Now, with these 2 nodes, what we're going to do is we are basically going to get their axis values and rotate the camera. So for this, we're going to go down to the My Blueprint panel, go to where we have our camera component and drag that in, go get camera, plug this into an add relative rotation node. And this add relative rotation, you can see here, it takes in a delta rotation. But to make things easier, we are going to right click on delta rotation and select split struct pin. This is going to do something very similar to the normalized 2D node up here, where basically it is splitting this data into its individual axes. So instead of having to plug in a full rotation, we can instead modify just the roll, pitch, or yaw. Now for the mouse Y, this is going to be moving our mouse up and down, and that is going to adjust the pitch of the camera. So we're going to plug that axis value into the delta rotation Y. And for the X, that is going to make us look left and right, so that is going to adjust the yaw. And then we also want to plug the execution flow into that node as well. So we can then save that, compile it, press play, and now if I move the camera left, you can see we can now look around as we do. And we can also move as well, but if I look to the left, for example, and press W, I start moving to the right. And that is because our movement is not mapped to the direction that our camera is looking, but rather we are moving relative to the world global coordinates, okay? So instead of what we want to do is make it so that wherever we press W, we move forward not relative to the world, but relative to the direction the camera is looking. So if I look over here to the right and press W, I want to move in that direction. I don't want to start moving off to the left here. So how can we do that? Well, first of all, we're going to skip that step just for now because there is one more issue that we need to solve. And if I press play, you may notice it. If I look up all the way and start looking around, you may notice that the camera starts to behave a bit strange. And that is because right now the camera is not limited in its rotation. Basically, our camera can rotate 360 degrees, which we do not want. What we want to do is clamp the camera's rotation so that it can only look a certain amount of degrees up and a certain amount of degrees down. That is going to prevent our camera from doing that weird glitch how it flips around and gets inverted. So, what we're going to do is we are going to get our camera here and we are going to plug this into a set relative rotation. Now, this rotation that we're going to set is going to be called after we add a rotation here, and this is going to basically be the clamped rotation. So for this, what we're going to do is we're just going to move it over here, move this over here. We're going to once again split this input into its individual axes by like so, and we are going to create a new node here called clamp float. Now clamp float, basically it takes in a value and it basically makes sure that the output is between the minimum and the maximum. So if we have a value of 10, for example, and the minimum is 0 and the max is 5, then the output is going to be 5. So what we want to then do is basically make it so that the camera's pitch, okay, its up and down rotation is clamped so that we can't look all the way up and around to do a 360. So from the camera, we are going to go get relative rotation. We're going to right click on this and go split struct pin so we get the individual axes, and we are going to plug the pitch into the value here. The minimum is going to be negative 80 degrees and the max is going to be positive 80 degrees. And this is then going to plug into the new pitch rotation here. Now we also need to make sure to plug in the roll to the new and the yaw to the new because we don't want to set these things to 0. Okay, so something like that is basically going to make it so that when we look up, we can only look up a certain amount of degrees, and when we look down, we can only look down a certain amount of degrees. So if we save this, compile and press play, we should now see that we can look around just like before, but if I look all the way down, our camera stops before rotating any further, and if I look up, we also have a upper limit as well. So there we go. Now we just need to solve this one issue of us not actually moving relative to the camera's direction, and for that we are going to be working on that in the next lesson. So thanks for watching, and I'll see you all then. Alright, let's continue on with our player controller. So we need to make it so that whenever we are rotating the camera and then move, we are moving relative to our camera direction. Now, the way we're going to do this is by first of all just moving this camera logic down here a little bit and going over to where we are having our movement nodes. So right now we are first of all getting our movement input, normalizing it, and then splitting up the axis into X and Y, so moving forward and back and left and right. But we are doing that based on world direction, not local direction. So what we're going to do is to move right relative, what we're going to do here is we are first of all just going to drag these things out a little bit so we have a bit more space. And for the world direction, we aren't going to be hard coding it here. Rather, we are going to first of all get our camera. So we'll drag in the camera, and we are going to get the camera's right vector. So we'll go get right vector. This here is going to basically return the camera's right direction, okay? So it's going to basically be pointing in the direction to the right of the camera at all times. And we're going to plug this into the world direction. Now, if we save that, compile and press play, what you'll notice is that when we move forward, it still has the wrong code working, but if I press A, we move right relative to wherever we are looking. So if I stand still and look in this direction and press D, we move over to the right, and if I press A, we move to the left, okay? So that is working nicely. Now we just need to set it up so that we can do the exact same, but for moving forward, but that's going to be a bit different, and I'll show you why. So, you may be thinking, okay, we'll get the camera's forward vector now, and that is what we're going to do. So we'll drag in the camera, get camera, we'll go get forward vector, so it's going to get the camera's forward pointing direction. We can plug that into the world direction here, save, compile, press play. And if we move forward, you can see as I look around, I'm just pressing W, and that works very nicely, okay? So we can now move in all 4 directions relative to where our camera is pointing. But if I'm moving forward and I look down, you'll notice that the closer I look to the ground, the slower I get. Now, why is that happening? Well, with our camera, it's forward direction. If we are looking down, it is going to be almost pointing to the ground. So the actual length of that vector that is pointing perpendicular to the direction we actually want to move is going to be shorter, okay? So what we need to do is basically get this forward vector, but cancel out the vertical angle, cancel out the pitch, so that the forward vector is pointing forward always. Now, I'll get up paint just for a second here so we can better explain what's going on. Basically, we have our camera here, okay, pointing out, and our forward vector is basically going to be whatever this camera, its direction is. So if we have our camera looking up, then our forward vector is going to be pointing in this direction as well. Now, what happens if our camera is pointing down pretty much straight to the ground, okay? Well, then that means our forward vector is very, very on a sharp angle down, and the ground is here, okay? So you can see then how the vector is, it's trying to push us into the ground rather than push us across the ground. So what we need to do is basically convert this so that instead of pointing always in the direction the camera is looking, rather it is going to be pointing, basically, it's going to be pointing relative to the world's local up direction, okay? So something like this. Now, it may be a bit hard to visualize here, but basically what we are doing is we are canceling out the pitch of our camera's forward vector. So, to implement this, what we're going to do is we are going to get our forward vector, we're going to delete that little connection there, and we are basically going to split this return value into its individual axes, and we are going to then plug this into a make vector node, which is going to basically remake a vector. And we want to plug in the X and the Y, but not the Z, because the Z is what defines the verticality. We are then going to plug this into a normalize node and plug this into the world direction. Now, if we save, compile, and press play, we should now be able to look up and down, and no matter how close to the ground we are looking, we are still going to be moving at full speed. So if I move forward and look down, you can see we are moving at full speed, no matter the angle of our camera now, which is very nice. Okay, so that is basically our looking and our moving setup. Now, one more thing we're going to do is look at changing some of the settings for our movement. So if we go over to our character movement component here, you'll see we have a bunch of different settings. We have gravity, max acceleration, stuff like that. Now, I'm going to go down here to walking, and this is where we can change stuff such as the walk speed. So right now, you can see our max walk speed is at 600 centimeters a second. If I bump this up to 1,000, okay, you'll see that we are moving especially fast, probably a bit too fast for what we want, so I'm actually just going to bring that back down to the default 600. But one thing I do want to change is going to be down here where we have air control, okay? So you can see air control right now is at 0.05, and this basically means how much control do we have over our character when they're in the air. So if I press play, and if I jump and then move, you can see that I don't really move that much while I'm in the air. And if I'm moving and jump, you can see I keep that momentum even if I let go of the keyboard after I jump. Now, in most games, you probably want a bit of air control just so that you can have more maneuverability. So I'm going to bump the air control up to around 0.5, and that should mean we have about 50% of our control while in the air. So if I jump and now move, you can see I have much more air control here. And I think that just overall makes controllers feel a bit more tactile and easier to control when you're running and jumping around. So, feel free to go through the rest of the settings here as well. There are a large number of different ones as well. You can change the max step height. So if you have steps, you can change how high you're able to actually step up without having to jump. Max floor angle, this defines the angle at which you'll be able to walk up. Anything greater than that, and you'll just be sliding down. Ground friction, max walk speed. You can even have many other things, as you can see here scrolling through. So yeah, this is a very versatile character controller, and you can use this as well for NPCs too, if you wish in the future. But for a player controller, yeah, you shouldn't really need to actually add any of your own components or logic on top of this, as generally anything you can think of with a player controller in a game like this, in a survival game where you might be running, jumping, this component should have everything you need. So thanks for watching, and I'll see you all then in the next lesson.